Good morning, students. Have you experienced that some of the food that we eat is sour in taste and some of the food that we eat is bitter in taste? Do you know the reason behind this? Let me tell you. This is due to the acidic and basic nature of the food. The food that is sour in taste is acidic in nature and the food which is bitter in taste is basic in nature. So we can determine the taste of the food from its we can determine the acidic and basic nature of the food from its taste. Okay, so students, today we are going to start the chapter number 2, that is acid, base and salts. So first of all, what are acids? As I have told you, acids are the substances that are sour in taste and they change the color of blue litmus to red. Now what is litmus? Litmus is nothing. Litmus solution is a purple dye that is extracted from lichen, a plant of Thylophyta division of plant kingdom. Okay. So we are covering acids first. Right. I have given you the properties of acids that are sour in taste. Right. They change blue litmus to red. Another property of acids are acid contains H positive, that is hydrogen ion in aqueous solution. Right. Next is that is acid when react with a metal leads to the evolution of hydrogen gas. For example, acid like sulfuric acid, that is H2SO4, when it reacts with zinc leads to the formation of zinc sulfate plus evolution of hydrogen gas. Right. So acids are classified into strong acids and weak acids, students. First, the strong acids. The acids which are completely dissociate into its ions are strong acids. Completely dissociate means completely break down. For example, this is a formula of HCl, hydrochloric acid. It will get break down into H positive and Cl negative. H positive means hydrogen ion, which is a speciality of a acid. So it completely dissociates, it's a strong acid. Another example for a strong acid is H2SO4, that is sulfuric acid, HNO3, that is nitric acid. Right. Like strong acids, we have weak acids. Weak acids are the acids which are partially dissociate into ions. Examples for the weak acids are CH3COOH, that is acetic acid. Do you know vinegar? Vinegar is used for making pickles in our homes. It is made from acetic acid. It's a weak acid. Another example is HCOOH, that is formic acid. Right. Next is bases. Bases are the substances which are bitter in taste and soapy in touch. The soaps which we use in our washrooms are basic in nature. Right. So acids change blue litmus to red, but bases change red litmus to blue, opposite of acids. Acid contains H positive ions in aqueous solution, base contains OH negative, that is hydroxide ions in aqueous solution. All bases are not dissolved in water. The bases which are dissolved in water are called alkali. They are highly reactive. So students, like acids are classified into strong acids and weak acids. Bases are also classified as strong base and a weak base. Okay. Completely dissociates into its ions are strong and partially dissociate into its ions are weak bases. Example for strong base are KOH, that is potassium hydroxide. K is the element name of potassium, right? NaOH, that is sodium hydroxide, right? When it completely dissociates means K positive and OH negative. So OH negative means it's a basic in nature, which is a specialty of base, that it contains OH negative hydroxide ion in aqueous solutions. Right. So these are the examples of strong base. Now we have the weak bases which are partially dissociate into ions. An example for weak base is magnesium hydroxide, which is called milk of magnesia. It is an antacid to get rid of indigestion and acidity. So now, students, how much an acid is strong is or weak means the strength of an acid. We can measure the strength of an acid and base from pH scale. pH stands for power of hydrogen ion concentration. It's a scale that ranges from 0 to 14. 0 being highly acidic and 14 means basic. Being 7 is a neutral. So when we go from 7 to 14, thank you students. So students, how strong an acid or base is? We can measure the strength of an acid and base from the pH scale. pH stands for power of hydrogen ion concentration. P is it's a German term. P stands for potence. It's a scale that ranges from 0 to 14, 0 being highly acidic, 7 is neutral, and 14 is highly basic in nature. Right? So, when we go from left to right, the OH negative means basic concentration will increase, and when we go from right to left, that is H positive hydroxide ion concentration will increase, means acidic nature will increase here. So it's all about pH scale. Thank you students.